Now we will go through the major glands of the endocrine system. So that this video is not too long, we will cut it in half. The first video will have the hypothalamus, posterior and anterior pituitary glands, the thyroid gland, and the parathyroid glands, as well as the adrenal glands. And in the next video, we will cover the pancreas, testes, ovaries, thymus, and finally the pineal gland. Let's get into the hypothalamus first. The hypothalamus can be seen as like the president or CEO of the endocrine system, as this is where we kind of connect the central nervous system with the endocrine system. The hypothalamus is going to help regulate many different activities of the body, including heartbeat, body temperature, and water balance, as well as glandular secretions. The hypothalamus will produce some of its own hormones, as well as influence the anterior and the posterior pituitary glands. Let's look at that posterior pituitary gland first, and then we'll get into the anterior pituitary gland. Like we mentioned before, the hypothalamus does produce some of its own hormones, two of which are ADH, or antidiuretic hormone, and oxytocin. However, the hypothalamus is not able to store these hormones. Instead of storing it itself, it sends both of these hormones down to the posterior pituitary gland to be stored and secreted away as needed. If we remember ADH from the urinary system, ADH is going to help us reabsorb water back into the bloodstream. Oxytocin is a different hormone that is involved with uterine contractions during childbirth. It's going to help move childbirth along so that a baby can be born. It also will help release milk when nursing. The anterior pituitary gland is also influenced by the hypothalamus and makes many of its own hormones in response to signals being sent by that hypothalamus. Here are some of the hormones that we produce in the anterior pituitary gland. We produce thyroid stimulating hormone, or TSH for short, which, as the name implies, stimulates the thyroid. The adrenocorticotropic hormone, or ACTH, which will stimulate the adrenal cortex. Gonadotropic hormones, of which there are two, luteinizing hormone, or LH, and follicle stimulating hormones, both of which will stimulate the gonads. Prolactin, which stimulates the mammary glands to produce milk, and growth hormone, which promotes overall growth of the skeletal and muscular systems. Let's look at how we influence everything all together. Up here we have the hypothalamus, the posterior pituitary, and the anterior pituitary. The hypothalamus will produce things like ADH and oxytocin and send them down to the posterior pituitary for storage, and the posterior pituitary will then secrete these two hormones out as needed. The hypothalamus will also influence the anterior pituitary through a series of different hypothalamic releasing and inhibiting hormones. The anterior pituitary gland has many different functions and many different hormones produced, including the thyroid stimulating hormone, adrenocorticotropic hormone, gonadotropic hormones such as follicle stimulating hormone and luteinizing hormone, growth hormone, and prolactin. Speaking of growth hormone, there are occasions where too much or too little growth hormone is made at various stages of development. If there is too little growth hormone early on in childhood, the result is pituitary dwarfism, which will permanently leave a person with a small stature. If too much growth hormone is produced during childhood, the person has gigantism. This can result in poor health for that person. Sometimes growth hormone is made too much in adulthood. This can be because of something like a tumor on the pituitary gland. The result is acromegaly, which result in larger than normal hands, feet, as well as facial features like the chin and nose. Moving on to the thyroid gland. The thyroid gland is a butterfly-shaped gland located just below the larynx. The thyroid gland produces several hormones, including T3, T4, and calcitonin. Both T3 and T4 require iodine. If the thyroid does not receive iodine, it cannot produce its hormones correctly. So the thyroid hormones can be broken down, like I said, into T3 and T4, both of which will help maintain metabolism. Calcitonin, the third hormone I had mentioned, will help to lower blood calcium levels. It does so by telling the bones to pull calcium from the blood and deposit it into the matrix. Sometimes things can go wrong with the thyroid. If someone doesn't have enough iodine in their diet, the thyroid will enlarge. This is called a simple goiter. Other abnormalities include hypothyroidism. This is where thyroid hormones are not made in high enough levels or not found in high enough levels in the bloodstream. There are two different versions, congenital hypothyroidism and myxedemia. Congenital hypothyroidism is where the thyroid does not develop properly, and so this is something someone was born with, and they have a short, stocky neck, as well as cognitive delays. Myxedema is hypothyroidism in adults. Someone with hypothyroidism as an adult would feel very lethargic, have trouble maintaining their weight properly, and would gain weight even without trying or without eating excessively, and even when they're exercising properly. They may lose their hair, they would be very intolerant to cold, and they would have skin problems. Hyperthyroidism is the opposite. The thyroid hormones are made in excess and are found in too high a levels in the blood. One of the examples of this is the exophthalmic goiter. The enlargement of the thyroid is one of the major characteristics, as well as protrusion of the eyes, hyperactivity, and insomnia. A thyroid tumor can also cause hyperthyroidism. A person with hypothyroidism may at first experience a rush of energy and feel very good. However, the hyperactivity and the lack of sleep due to insomnia will eventually wear that person down. They may also experience things like anxiety, which can be very disconcerting. Here's some images showing some of these abnormalities. We have the simple goiter over here, where you see that enlargement of our butterfly-shaped thyroid, congenital hypothyroidism, and the exophthalmic goiter, which is causing bulging of the eye. The parathyroid glands are 4 small glands that are embedded on the back of the thyroid gland. They produce a hormone called parathyroid hormone. Parathyroid hormone serves to function as the opposite of calcitonin. Remember that calcitonin lowered blood calcium levels by increasing bone density. Parathyroid hormone works opposite of this, increasing blood calcium levels by promoting the breakdown of bone. It also promotes the reabsorption of calcium by the kidneys and the absorption of calcium by the intestines. Let's take a peek at blood calcium regulation and how these two hormones help maintain homeostasis. If our blood calcium level is too high, our thyroid gland will secrete calcitonin into the bloodstream. That calcitonin will cycle around throughout the bloodstream and be received by the bones. This is our target organ. The bones will take up calcium in blood in response to calcitonin, thereby lowering blood calcium levels. If we lower the level too much and we don't have enough calcium in the blood again, the parathyroid glands will release PTH in response. PTH will arrive at their target organs, including the bones, kidneys, and intestines. Blood calcium then will rise, and we return back to normal. Let's get to our last organ of this video, the adrenal glands. The adrenal glands are glands that sit on top of the kidneys. Here we see the kidney and the adrenal gland kind of lopped over the top. And the adrenal gland has two parts, the adrenal cortex, which is this outer layer, and the adrenal medulla in the middle. The adrenal medulla is controlled by the nervous system, whereas the adrenal cortex is controlled by ACTH produced by the anterior pituitary gland. The adrenal gland is very unique in that it does have controlling. The adrenal glands are unique in this case because they have parts that are controlled by the nervous system specifically and parts that are controlled by the endocrine system. Let's look at the inner portion first, the adrenal medulla. The hypothalamus will stimulate hormone secretion in the adrenal medulla. These are for short-term response to stress. Epinephrine, also known as adrenaline, and norepinephrine. Both of these are short-term responses to stress, aka your flight or fight response. These are hormones that allow for you to respond quickly to a potentially dangerous situation, a situation that you may need to fight or run to get out of. The adrenal cortex is the outer portion of the adrenal glands. The adrenal cortex is similar to the medulla in that it also is going to produce hormones that respond to stress. However, the cortex handles long-term response to stress as opposed to short-term. There are two major types of hormones coming from the adrenal cortex. Mineralocorticoids, which help regulate salt and water balance, like aldosterone, and glucocorticoids that regulate metabolism and suppress inflammation, like cortisol and cortisone. Let's look at a quick summary of the adrenal glands, as we see a good marriage between the nervous system and endocrine system here. The hypothalamus will trigger a nerve impulse down the spinal cord when talking to the adrenal medulla. It's important that we use the nervous system to communicate with the adrenal medulla since this is a short-term stress response. If the danger is clearly present, we need to be able to act fast. Changes need to happen within seconds. Our connection through the nervous system for this allows for that very fast response so that epinephrine and norepinephrine can be released immediately. For long-term stress response, it's not as worrisome to have such a quick pathway. Therefore, instead of using the nervous system to communicate with the adrenal gland, we instead use the endocrine system with the anterior pituitary gland secreting adrenocorticotropic hormone to stimulate the adrenal cortex. We can then regulate metabolism, reduce inflammation, as well as maintain blood volume and pressure, and maintain sodium and water levels. However, sometimes these glands can malfunction. Addison's disease is one of those conditions where there is a hyposecretion, meaning there is too low of a secretion of glucocorticoids by the adrenal cortex. One of the main symptoms of this is the bronzing of the skin. Cushing's syndrome is the opposite. There is a hypersecretion, meaning secretion is too high of glucocorticoids. This is characterized by weight gain in the trunk of the body. However, the arms and legs don't experience the same weight gain.